I'm going to be showing you how to never get another trig equation wrong again. I'm going to be doing that in under 20 minutes. And if I can't, if you don't feel that has achieved the same, then I invite you to dislike the video. Enjoy. Alright, so firstly we need to look at the common mistakes. Okay, and that's a very important point. First one is mindlessly using cast diagrams. So for instance, you get two answers and you mindlessly just do 180 plus x, for instance, right, without actually checking if the solution actually makes sense. Or you do 180 minus x, and again, you're not really thinking through it, you're just doing it mindlessly. In many situations that's fine and you'll get the answer, but as you'll see, there's many situations where that's simply not applicable. Number two, not finding all solutions in the period given. Okay, so naturally you get given a period, usually it's like 0 to 2 pi, and you need to find all the solutions in that period. But sometimes it'll extend out to 4 pi and or another period that they want, and in that situation, again, the common mistake is you're not fully extensively finding all solutions there. And that's especially true if you've got 2 theta equals something and then you need to half it, and we'll go through how to do that as well. Lastly, and this links in with the first one, is when tan x is negative. This is a common one that catches people out, and usually people resort to blindly using the cast diagram for this. Again, not really applicable, but there's a very simple solution that essentially solves and covers all three of these. So without further ado, let's get into it. Alright, so for our first question here, it's 2 sine squared theta plus sine theta equals 0. So I'm going to skip the first part and I'm going to say, well, listen, sine theta is going to equal 0, which means that theta is going to equal 0 or pi. Okay, and the other side, we've got 2 sine theta equals -1, which means that sine theta is going to equal -1/2. Okay, so we've got values for theta here and they're within the bounds. That's fine, we can check that off. But what about this part? This is where things get interesting, and this links back to using the cast diagram correctly. So if I draw the cast diagram here, okay, what does that give us? Well, as you know, sine must be positive in this quadrant and in this quadrant. So therefore that implies that sine must be negative in this quadrant and this quadrant. Again, because sine theta is equal to -1/2. Okay, so what I'm going to do here is I'm actually going to draw what I like to call reference triangles, which makes the question way more simple. Okay, because now what we're going to do is we're going to solve for theta in these individual triangles. Okay, instead of looking at things on a grander scale, we're just going to be solving for theta in these individual triangles. And when we do that, we've got theta here, theta here, we've got 1 here, 2 here, 1 here, 2 here, and these are right angle triangles. Now we've got 1 here, 1 here, 1 here, and 2 here, 2 here, because what does sine equal? Well, sine equals opposite over hypotenuse. Opposite over hypotenuse, right? So this makes sense. And so we can say, well, look, very simply, we can say that, well, sine, so arcsine of half is going to equal pi over 6. Now, if arcsine is equal to pi over 6, what that means is, okay, we've got that. That's our reference angle. So that's our little angle here, right? And so what we need to do is account for where it is in the cast diagram. Okay, so as you can see, I'm not mindlessly using this. I very much just worked out the reference angle here, firstly, in a concrete step. And now what I'm going to do is I'm going to say, listen, in this quadrant, what have we got? What's 180? Or better yet, in this example, pi plus theta. And in this quadrant, we've got 2 pi minus theta. Okay, so if we address the first one, this makes sense. Pi, theta. Okay, so it's pi plus theta. So therefore, we've got theta is going to equal pi plus pi over 6, which equals 7 pi over 6. Now for the second one, Okay, we're going all the way around, and as you can see, this makes sense again. It's 2 pi, which is the whole thing, minus this. Okay, and so what's that going to give me? Well, theta is also going to equal, as a result, 2 pi minus pi over 6 is equal to 11 pi over 6. Okay, and as you can see, we've got these answers, and that's going to be the final. These are going to be your final answers within that range. There's nothing else we can really do. Alright guys, now for question 6, we're going to jump straight into B, and specifically we're going to jump straight into the second half of B, because we've already worked out this question before in previous videos, but we're going to go from cos 2 theta plus 57.688 degrees is equal to 1 over root 7, right? So, perfect. Now, very simple from here, we're just going to say, well, 2 theta plus 57.688 is equal to arc cos 1 over root 7, which gives us 67.792, right? So we've got an interesting thing here. So what I'm going to do here is actually set this equal to k, okay? Because what this implies is that we've got a new angle, k, which we're going to work with the cast diagram. So I can say let 2 theta plus 57.688 equal k. Okay, so therefore I can say, well, k is going to equal 67.792, or what else can k equal? Well, this is where things get interesting, because I can say, well, remember we're working with cos, so if we jump to our cast diagram, we're going to be dealing in these quadrants, aren't we? So if I draw my triangles here, we got our thetas here. Okay, so what does that mean? Well, our reference angle is going to equal, well, we got 67.792 here. Okay, if we take that around, okay, remember this is going to equal to 360 minus theta, right? And so what's that going to give us? $67.792. Okay, so therefore k is equal to 67.792, or k is going to equal 292.208. Okay, brilliant. Which means that 2 theta now is going to equal what? Well, if we minus 57.688 from both of these, we get 2 theta equaling 10.104, or 2 theta equaling 234.52, which means theta is going to equal 5.1 degrees, or theta is going to equal 117.3 degrees. Okay, and those are going to be your final answers for that question. Right guys, now for question 4, we can skip right into it as well. So you can go to the previous video to see the full working, but essentially what we get here is tan theta is going to equal plus minus 1 over root 5. Okay, so that gives us two things, right? Because we've got a positive and a negative, and hence a common mistake can occur here where tan is negative. Now, the trick in this situation is not to freak out. Firstly, let's address the positive. Okay, if we address the positive, tan theta is equal to 1 over root 5. Okay, which means that theta is going to give us 24.1 degrees. That's fine. Now, this is where things get interesting. If we go back to our cast diagram, where is tan negative? Well, tan is going to be negative. Well, tan is positive in these quadrants, so therefore tan is going to be negative in these quadrants. Now, this is where the common mistake comes in about mindlessly using cast diagrams, because oftentimes people will just randomly plug in a value here or whatnot. So we need to think about this methodically. And what I like to do is, again, draw the triangles. Okay, draw yourself the triangles. And what we're going to do is we're going to work out theta in each of these triangles. which is going to be the same, and then we can apply our rotations. Okay, so tan theta is equal to 1 over root 5. Okay, so opposite over adjacent, opposite adjacent, okay, opposite adjacent, right? Now 24.1 is going to be our reference angle. So what does that tell us? Well, what we've got here is 180 minus theta. Okay, so therefore we've got 180 minus 24.1 over here. And over here, we've got 360 minus 24.1. Okay, so 180 minus 24.1, 360 minus 24.1. So theta then is going to give me what? 155.9. 360 minus 24.1. Again, don't think minusly here. It doesn't fit within our bounds, so we can't accept it. But we can accept 155.9. So therefore 24.1 and 155.9 are going to be our final answers to that question. Alright guys, now for number II, 5II. Again, going to skip to the second part. So what we're going to get really is a sine, okay, of 2 theta plus 22.08. Okay, and that's going to equal 2 over root 7, right? Which means what? And what that means is 2 theta plus 22.208 is going to equal 49.107 degrees. Okay, perfect. So what do we do now? I'm going to set this equal to k. So let (22.28) equal k. Now, this is a interesting one because we're working with sine again, right? So cast diagram. Okay, and we draw our reference triangles. Okay, so we got k here, right? So k is going to equal 49.107, or it could equal 180 minus theta. Okay, so it could also equal 130 could equal 130.893, right? That means that 2 theta is going to equal, in fact, let me work this up properly. So 22 to 8 is going to equal 49.107, or 2 theta plus 22.08 is going to equal 130.893. Okay, which means that 2 theta is going to equal 26.899. 2 theta is going to equal 108.685. Okay, which means that theta is going to equal 13.4, or theta is going to equal 54.3. Okay, those are your final answers, and they are within our bounds, and we can't go any further than this, right? We can't go any further because these are our only solutions. Alright guys, so now we've got this question where the common mistake a lot of people will make is with 2x being theta, they're not going to be able to find all the solutions. So let's quickly run through this. So 2x is going to equal to arc cos of a half, okay, which means that 2x is equal to pi over 3, right? Nice. So we're going to say let 2x equal theta. So what we've got here now is, if we go to our cast diagram very quickly, okay, remember it's cos, so C A S T. Got triangles here, okay. Okay, so this is our reference angle, and over here it's a 360 minus a theta, or 2 pi minus theta in this case. So what we've got then is a theta is going to equal pi over 3, or theta is equal to 2 pi minus pi over 3, which equals 5 pi over 3. Okay, so we've got 5 pi over 3 there. What we've got then is theta is equal to pi over 3 plus n times 2 pi, or 5 pi over 3 plus n dot 2 pi, because we're accounting for the fact that we're within the period of cos, okay? Obviously it's a periodic function here. So now we can say, well, with n equals 1, if n equals 0, we get these solutions, right? But if n equals 1, what solutions do we get? We get theta is equal to 11 pi over 3, or 7 pi over 3. And if n equals 2, theta is going to equal 17 pi over 3, or theta is going to equal 13 pi over 3. Now remember that with n, this is our period here, so we can't go below 0. So if n, it can't be below, it can't be below 0, right? So we're only talking positive n's here. So remember though that theta is equal to 2x. So if theta equals 2x, then we got to divide our answers by 2, right? And what that gives us then is, well, let's start at the top. We divide these by 2. We get pi over 6 and 5 pi over 6. Still within bounds of 0 to 2 pi. If we divide these by 2, we get 11 pi over 6 and 7 pi over 6. Okay, within the bounds. We divide these by 2. Okay, then we get 17 pi over 6 and 13 pi over 6. However, these are obviously not within the bounds of 2 pi because they're bigger than 2 pi. So therefore, these alone are going to be your final answers to that question.